I'd like to thank, well, first of all, Google for hosting us and Guido for being willing to come and discuss with us basically the intersection of the evolution of the Python language and the growth of the scientific community. And this is meant to be mostly an open discussion. David Cournapeau, Travis, and I are going to semi-organize the conversation with Guido, but we hope that anyone who has thoughts on this brings it up. So to organize the conversation, I guess the start is that on the one hand, Python is growing massively in scientific computing. That's the reason why many of you guys are here. Guido was at one of our SciPy conferences, but the success story of Python in scientific computing continues to sort of rise. On the other hand, the main core development team put Python 3 out already, what, 2 years ago maybe?
It's probably more like 4 years ago.
Okay. Well, that isn't, the fact that I don't even know is an indicator of the issue that we want to talk about, which is the fact that in our community, the bulk of us have barely migrated. Now, the core tools in kind of the base layer of what we consider to be the scientific Python stack, NumPy, SciPy, Matplotlib, IPython, of those, Cython, SymPy, most of those tools have had in the last few months, or some of them up to a year, Python 3 releases. So for example, NumPy, SciPy, and IPython, the current official versions, run on Python 3 out of the box. You type Python 3 setup py-install, it works.
That is awesome news, by the way.
That is true.
Congratulations.
So that's kind of the status of the tools. Matplotlib hasn't had a release with Python 3, but all of the code is merged in Git master, and John Hunter, who's in the room, can let us know, or is at the meeting anyway. They're basically talking about when to do the release, but it's a matter of probably a few weeks or maybe a month or so, because the Python 3 test suite passes and the code has already been merged. So the basic layer of the tool stack has been ported to Python 3. On the other hand, so the higher layers haven't, and there hasn't been too much adoption of Python 3 in the scientific community at large. Most people continue to work on Python 2. So I guess one way of driving the conversation about shifting is the community is moving there, the core development team, that is the version which is being maintained. You should move to it. We are sort of thinking also about, in addition to you should move it because it's the right thing to do, what things could be perhaps done in Python 3 to make it even more exciting for scientists to want to move. Because they might say, wow, I actually want to shift to a Python 3 workflow because X and Y features make my life much, much easier, or would allow me to do things I can't do right now, or solve problems that I currently have. And I think the perception is that right now, there isn't a major gain for us in Python 3, and so people just continue to work on Python 2, especially because for most of us, Python is a means to an end, and we're not developing Python itself. So maybe Travis can say a few things from your experience in industry and in other contexts of what you've seen on that adoption, and then based on that, we can try to go on specific topics and try to have a conversation.
I'm not sure I have a lot to add beyond what you just said, Fernando. I mean, I can say, having seen a lot of adoption of Python in industry, there's a lot of hesitancy to move the stack to Python 3. I mean, most people say, they've asked me or said, when should we move to Python 3? Or I've asked them, when are you going to move to Python 3? And it's either never to, well, we'll see when the tools get to where the tools I rely on are there. So it's very slow. And certainly some of the large organizations. Now, people that make small use of Python find it easy to move to Python 3. I mean, they start with Python 3, they can use Python 3. But it's the places where it's really heavily used. I think it is more I would like to emphasize the sort of the carrot more than the stick. I mean, right now, I think that is the perception that Python 3, it has a few nice features, but not really anything that's sort of compelling to certainly a technical user or a scientific programming user. So I guess that's pretty much all I had to discuss generally. We can talk kind of about some of the possibilities, maybe get Guido's response to some of our initial questions if he has any, or maybe advice as to what we can do to try to promote some of the ideas we have. One of the things I've noticed over the past, I guess, 4 or 5 years is early on there was a really strong connection between the scientific computing community and the core Python developers. Probably over the past 4 or 5 years, that hasn't maintained as strong. Some of it's been us. I mean, certainly we don't have enough people who kind of bridge both camps. I think, and the Mark Dickinson is certainly somebody who has contributed code to the floating point, and he's sort of been able to be in both groups. I was trying to do that for a little while, ended up too much. I couldn't do both. It was too much. I didn't have the time. and I haven't found other people who have sort of stepped up and been willing to participate in the Python dev as well as participate in the NumPy dev or SciPy dev. So I think that's contributed to some lack of communication, lack of the same kind of high bandwidth discussions that occurred early on in the origins of Python. So comment on that, feedback on that.
I don't know if you have it, yeah.
I don't think you need to feel bad for not straddling core development and NumPy development. I think that pretty much everyone else who is, or every other community who are developing a tool or a framework or a library or a collection or a suite of those things for a particular application area is pretty much in the same boat. We don't sort of hear a lot from the web development community either, for example. The Django folks mostly go off and do Django stuff, and
Twisted folks go off and do twisted stuff.
Exactly, and often there's one or two key figures who occasionally pipe up in discussions and who appear to be following the Python dev or Python ideas mailing lists to some extent, but they also often sort of disappear for months or years at a time, and I don't see that as a particularly big issue.
Okay. One of the things I have noticed is it's rare the person that gets involved with Python dev that has the background from the scientific computing. Whereas if there's several I know who have the background in web development who maybe they're not doing that primarily, but they at least understand the use cases a little better. That's where I felt it's been really helpful to have somebody who has at least some background in the use cases of a technical computing or a scientific computing community participating in that Python dev discussion. I don't know, I mean, are there people now that maybe I'm just not aware of who kind of fill that role?
Well, people's email addresses usually don't come with an affiliation, and they don't necessarily sort of state I am representing the NumPy or SciPy community.
Sure.
So I often don't know,
Sure.
to be honest. I sometimes don't even know who is a core developer, because I'm actually, you may have heard me joke about retirement the last couple of PyCons. Yeah. I'm still sort of feeling I'm involved in certain types of major decisions and sometimes micromanagement of the core development, but there's also a lot of stuff that I really don't need to be involved, and I've fairly effectively delegated a whole bunch of responsibilities. I have no idea what's going on in the bug tracker or even in the Mercurial repository most of the time. Yeah. I think one thing I hear is that that you may have a reason for wanting a tighter connection between the NumPy or SciPy community and core Python, because in some cases, language features really matter for you. Yeah. This morning you touched briefly on things like complex numbers, extended slice notation. There is, of course, the infamous PEP 3118, where I don't know if you're aware, but finally, very recently, someone whose name I have unfortunately forgotten has implemented the final bit of that PEP.
I know. I'm very aware of that, actually.
Okay, good.
I'm very aware and very cognizant of sort of the memory view was left unimplemented.
Yeah.
Right, and sort of relied on somebody jumping in and trying to figure that out who didn't have the benefit. And it illustrates one of the challenges of that. People who use NumPy actually don't necessarily, wouldn't use the memory view, but the people who do, one thing I saw that I loved was that there's a SQL interface now that uses memory view. So finally, for the very first time, that idea that I had wanted to see, which was raw direct copies from SQL databases to NumPy arrays, can now happen, right? Without unboxing and boxing, that everything else usually does. And no, I'm very aware of that. Very grateful to the folks who have stepped in and done that. Actually, I still get the messages.
Well, there you have one of your carrots.
Yeah, no, that's right. No, that's right.
Potentially.
Potentially. Although if somebody installs NumPy, the carrot is the sequel, the someone making MX SQL or a SQL driver going, oh, I'll just support the memory view. Or Python writers going, I'll support memory view, and then that allows them to. But the buffer protocol gave them that. The memory view object wasn't as necessary, so that's one reason it was a nice thing.
Remained unimplemented for so long.
Remained for so long because it wasn't the key long pole. That's very good insight. Thanks, though. Appreciate that. How do you want to proceed, Fernando? Do you want to kind of go regarding those language features?
Yeah, maybe we can dig into specific language features, which I think perhaps are some of the main ones. And afterwards, we have David, who's going to talk about packaging and distribution, which is basically the eternal thorn on our side and is an important problem. But first, perhaps there's the whole discussion on PEP 225, and that discussion has ranged from let's go ahead and have the scientific community would like to have the full PEP 225 implemented. I briefly.
Can you remind everyone here
Yes. So
what PEP 225 is?
So
What's he doing the map? Internal map?
So you folks anyone can, if you simply Google PEP 225, you will find it. But it's
You're not going to tell them, right? You're going to make this completely abstract. You're just going to ask me to say yes or no, but you're not going to let anyone know what I'm actually going to say yes or no
Exactly. It's a PEP about adding for every existing binary operator in the language a second version of it. Prepended in the PEP, the current kind of candidate character is a tilde character. So just like you have A star B for multiplication, you would have A tilde star B. And that new operator would be also a special method with double underscores, which objects could implement their own semantics for. And the star, I'm starting with the star because it's specifically the one that we as a community care the most about, because it will allow us to implement matrix multiplication semantics that are different from element-wise multiplication semantics. But the PEP is not focused on a single operator. It actually, the specification of the PEP is to create these cousins, these tilde cousins for all binary operators. I personally would like to see division, a tilde division that would divide into the rationals instead of dividing into the floats, because Python has a rational class built in. It's in the standard library, but syntactically it's kind of clunky to use. So if you want to express 2/3, instead of saying 2/3 or 2 tilde/3, you have to say rational open parens 2 comma 3 plus rational open parens. So anything that brings the language closer to the mathematical notations matters for us. And we could find other uses for some of the other operators. Now, the discussion has wavered within our community between go full PEP, it would be great to have all of it, and some people who say, as long as I get the multiplication, I don't care about the rest, and somewhere in between. And there's another PEP, which is PEP 335, which is about allowing operators to also implement their own semantics for the and or keywords of the language. Currently, you can implement the binary ampersand and vertical bar. Those are available to you. You can define objects with your own semantics, but not for the and or the or keyword. The language doesn't offer any extension points. And PEP 335 suggests allowing those. And for that one, I personally don't have in my head why that one would be much more important. But a number of people said during the discussion about PEP 225 that they would love to see those two woven, basically happening together, their value would be greater than their individual parts. Maybe Travis has something to say about that. I'm not exactly sure. So,
is the PEP 335 the and or PEP?
Yes, 335 is the and or, 225 is the tilde versions of all binary operators. And the summary of sort of from our side is that there's definitely strong support that 225 would make our lives easier on a number of fronts. So that's kind of one of the things that we'd like to hear from you. Is it feasible? Does it depend on us having somebody who champions the discussion and implementation? Is it a matter of give up and go home and stick to the language? And at this point, would kind of like to hear from you.
That's tough. To be honest, until this morning, and I saw your notes about this panel, it was my understanding that both those PEPs had been amply discussed and rejected.
Officially, one of them is in deferred status and the other one in draft status.
Really? Okay.
Yeah. So
see, that is where my
335 is in
memory is.
draft and 225 is in deferred. But none of them has been officially rejected.
Okay, so that leaves at least the door open a little bit.
You're almost dead.
355 has been. Excuse me? The and/or PEP has been sort of brought up several times, and each time that it was brought up on Python Dev, the conclusion was that there was no one on Python Dev, sort of no one amongst the core developers whose voice counts, who thought that sort of it was worth the cost. The thing is, every language change proposal has a cost. And so, I mean, the cost is not always very clear. I mean, first of all, every language change proposal has a cost that it makes the language bigger. That applies to pretty much every PEP, because nobody ever proposes in a PEP to delete a feature. Maybe there have been a few at the transition to Python 3000. And some of those deletions have now been undeleted. For example, Unicode literals are coming back as a porting hack in Python 3.3. But apart from the sort of the cost that every PEP has, the and/or PEP has the problem that every and or operator that occurs in the code will have to generate code. It's sort of the generated bytecode will be more complicated and execute slower because it would need to take into account the possibility that the result was one of those chained operations. And that sort of, even though various people have tried to show that the cost is actually very small, maybe it only is a single instruction that needs to be emitted. If you can sort of choose your opcodes, and of course we can, because we're not stuck to a particular virtual machine design. Every Python version can have its own evolution of the Python bytecode. Nevertheless, there is even one instruction takes extra runtime overhead, which would sort of, given the frequency of and or operators, and given that at the moment none of those make use of the feature that you're proposing here, all code will slow down by a few %. And that's a big cost to pay for a pretty esoteric feature. The most recent time that this particular and/or thing was discussed, someone brought up that even if the general and/or overloading wasn't supported, that we should perhaps at least do something about chain comparisons.
Yes.
Which I think might be a much more defensible position.
It's actually the use case people want, and it seems like it wouldn't have the potential problems.
So create the proper approach to do that is to shed all the baggage of the existing and/or PEP.
Make a new PEP.
And make a new PEP that proposes something like where chain comparisons are somehow translated into something that that can be overloaded in that fashion.
Yeah. That's reasonable. I think.
And chain comparisons occur way less frequently in sort of common code than and/or operators.
Right.
But they probably, relatively speaking, occur a lot more in your code, or they would occur more if they actually work the way you want them to work.
Exactly. Exactly right.
Yeah. So that's what I would recommend for the PEP whose number starts with 3.
Excellent. And on the matrix.
On the PEP whose number starts with 2.
Yeah. That's taken literally, that PEP would actually introduce about a dozen new operators, maybe 2 dozen if you also want to combine them with assignment. Because the sort of the first section of the PEP says we propose tilde operator for these 5 operators, but Python actually has about 10 or more different binary operators. There's a couple of extra ones that aren't listed there. And for every operator, we have also a combined with assignment version. And it would be sort of, from sort of a simplicity of the language point of view, it would be annoying to have some operators also support the tilde version and others not. That said, it sounds like many of the tilde operators aren't actually going to be very useful for you guys. The sort of I've heard over lunch a couple of arguments for a second multiplication operator. Let me ask you a question. There are actually already two different interpretations of star. One is how it works for built-in lists, where you can only do list times number, and then it actually repeats the list, so you get a longer list. And then you have your element-wise operation in NumPy. And apparently for objects that are of a special type matrix, there's yet another meaning which does matrix multiplication. If you got your sort of your extra operator for NumPy, which one would be matrix multiplication and which one would be element-wise multiplication?
We'd probably have to keep the star for element-wise, just because of backwards compatibility. There's 15 years of history dating back to the beginning of numeric on that, which would be really insane to try to break with. So I think we would, if there was another operator, we would keep the star for element-wise multiplication as is, and this other operator would be the matrix multiplication operator.
So that sounds like you're not even in favor of PEP 255 yourself, because as far as I can tell, that PEP proposes the tilde prefix as meaning element-wise, right? Or
well,
do I have the PEP backwards?
No, it's possible. It's possible that it proposes that. Honestly, I think we in the scientific community, the way we read it was because it's a new family of special methods whose semantics are free for objects to define, we would define them in this way. And we would, the NumPy would define double underscore, I don't know, tmul or whatever the thing is called, it would define it to be matrix multiplication. Even if the PEP guidance were to be for that one, to be for the reverse interpretation, I think the cost of breaking backwards compatibility for us would be absolutely prohibitive. I don't know, Travis, if you see it otherwise.
No, I agree.
That's good to know, because that means that the PEP as written is probably not exactly what you want.
We didn't write it.
Going back to proposing smaller, more focused proposals, it sounds like the only two operators where it matters are star and perhaps slash.
Maybe star, maybe power.
And power, yeah, because power is a derivative of star. And so, I mean, exponentiation is a composition of multiplication. So if you need special meaning for multiplication, you want special meaning for exponentiation.
But so it is that family.
So that matrix powers.
Well, yeah, that's sort of, for Python, star and star are completely unrelated, unfortunately, perhaps.
Yeah.
I mean, it's just by convention that star is repeated multiplication.
No, but mathematically,
well, yeah,
power is a composition of multiplications. So if we could have this other one, then a star 4 would be the fourth product of matrix product of a star, and it would allow us to compute matrix powers, which right now are computed with matpow, right?
Yeah, matpow, or else the matrix class does overload.
Or the matrix class overloads.
So people typically don't use the matrix class very often, because having this sort of, well, or they do it just briefly to do the array expressions, the matrix
so
expressions.
It was. I hate to just sort of point at you and saying you made a mistake, but it feels to me like the real issue is that the matrix class probably shouldn't have overloaded star.
Oh, we didn't want it to exist in the first place. But it was there.
Well,
if it was
so now we're proposing changes to the language to sort of deal with the mistake that you wish you had never made.
No, I'm not sure that's the right way I would color that. I mean,
Yeah, I didn't believe that for a second either. It's just sort of the words came out of your mouth that way.
No, it's that matrix multiplication, infix notation for matrix multiplication is so valuable that people would create a matrix subclass just so they could have a long expression that used matrix multiplication for some pattern. So we'd have to overload some operator. Now,
Well, you could just make it a method named .mul.
yes,
Which
They
we,
don't want that.
which we now have.
which we have. We have
Yeah.
dot.
In fact, the matrix class I think dates back to the days of old numeric.
Yeah, there was a
Right.
matrix class.
And
that
I
been around for a
guess
long
the
time.
other problem is that Python is dynamically typed, so that you could write code that thinks it's manipulating numeric arrays, and it's doing some multiplication there,
Yeah.
and somehow someone passes in a matrix, and now suddenly the code gets the overridden implementation of star for the matrix.
Right.
And so writing robust code that sort of does the right thing, does the sort of the array thing, because I think the matrix is a subclass of the array,
Yeah,
right?
no, it's challenging
Yeah.
actually. There were a few
Yeah,
bugs
so-
that were subtle.
It would be nice if there was a different symbol you could use
Yes.
there, whether that was a prefix
Right.
for a
Right.
star or something else.
I don't know if you've seen people have made classes, that funny class implementation where they've overloaded the OR twice, like the left OR operator and the right OR operator with an object in the middle that they spell with a letter.
gosh.
Yeah. and to do this, it's really it's quite a hack.
I believe it.
They built something that looks like an operator, which is or some object, another or, and that.
Oh, and the object is an
some
identifier,
funky
of
It's an
course,
identi- it's
and
just-
it has just very hacky
Yes.
overloading.
So it
of-
grabs its
Yeah.
arguments on both sides and wraps them into a matrix multiply. Hacks of that nature have been implemented.
So, yeah, so they're sort of the two ways I can see the proposal having more chance in some sense is either focus on just adding a second an extra symbol for a different kind of multiplication.
Yeah.
And I wish I could propose a good character for that, but I think you're going to have to pick it from the Unicode character set, which is unfortunately a major hurdle because nobody knows. There's no standardized way to type Unicode characters.
Yeah. I was gonna ask about that because there are a lot of nice Unicode characters, so it would work well.
Yeah, too many probably.
Because an APL doesn't mean there are a lot of good ideas.
But do you know how to type those? Any of those?
Yeah. No.
Yeah. So, yeah, the mathematicians are so used to just typing the latex names that maybe you want latex operators. It turns out that the backslash sort of outside a string literal doesn't have much meaning in Python. So you could try to go that direction.
There we go. As long as your editor shows it as a symbol.
Oh, come on! You can
Yeah.
you can read raw latex.
No,
You're a
no, that's
mathematician.
true, but-
All you mathematicians know how to read raw latex.
/times. Here we go.
So joking aside, the sort of the other direction I could see it going, I don't know that. I think that's probably not going to be feasible for Python 3.3, but it might be sort of an interesting thing if you can rally enough support for Python 3.4. Would be some way to introduce an infinite class of new operators. And
meta operator. Meta operators.
yeah, so the trick is always going to be what notation do you use that is guaranteed not to already have some meaning.
Yeah.
Gee, you could introduce backticks again because we carefully eradicated those from Python 3, so there's a new use for them.
Somebody write that down.
There is the backslash.
Yeah.
In which sort of
Yeah. Okay.
and
Peter.
there may
the
be
brackets.
other ideas possible there.
Yeah. Peter?
It was more along those lines in terms of a really big carrot would be sort of Nick Coughlin's proposal and things that like Armin.
I have no idea which proposals those are, so you'll have to
So AST
call them by
transformation-
value.
AST transformation hooks for DSLs in Python. That's really where that's
Yeah.
the beachhead that we're kind of washing up on.
That's yet another approach.
Yes.
Leave it out of the core language,
Yes.
but provide more
Yes.
options for transformations. That is something that in theory you can implement all by yourself, because you don't have to sort of hack it into the existing AST, because no two Python implementations have the same AST API anyway. So I really don't want to see PEPs that propose syntactic features or APIs that are limited to C Python. So you're probably going to have to come up with a completely implementation neutral version of those transformations. With sufficient caching and some other clever tricks, it's not even necessary that the transformation code is particularly efficient. So you could have an import hook that either recognizes different file name extension or just says, well, Python files can also contain this experimental syntax, or maybe they look for a special mark in the first paragraph of the file or something, and then they'll go do some kind of pre-processing, which can be sort of, you can have something quick and stupid based on a regular expression substitution, or you can have something really clever based on a complete parse. But in theory, you can create a system like that today and have it work with every Python implementation.
I know
Yeah.
4 separate people, myself included, well 5, including me, that have actually done this. And so this it just feels like you're outside of God's house.
And
So
is the solution, is the sort of the experience that it doesn't work very well, or that it's hard to convince people to adopt it?
It's that rather you feel like you're really sabotaging the core language, right? You're sort of like, you're outside of the language. Ultimately, you're doing some transformation, some string parsing to basically feed and munch some processed Python back into the Python interpreter itself. But then any of the additional wonderful introspection tools inside Python, they're not going to see anything of what you've done, right? They're going to see the transformed AST or whatever. And so all of these things feel like a one-time ingest of the code sort of hack. And what would be really nice, I think the AST transformation hook concept is to actually make it so you can sort of have a wildcard AST node that defers to a plugin for, in the language itself that basically says, okay, you handle this particular part of it. We're not going to kick back a syntax error. We know that that's not something we deal with. And so it's much more of a conversation between the interpreter and kind of the front-end DSL, rather than
Yeah,
just one time, like,
So I can just bounce back what I just said a minute ago, which is that you're now proposing something that is purely implementation specific. So in order to have any chance to have the core team adopt that suggestion, even if you did all the implementation work, if you gave it to us on a golden platter, we wouldn't take it unless you had a well thought out strategy for make that feature work in every Python implementation. It doesn't mean that you have to write the code for all of them, but you your proposal needs to be to support an implementation whose complexity is proportional to the importance of the idea for every other Python implementation around. And that would mean at least Jython, IronPython, PyPy, and CPython need all sort of be treated on equal footing. As far as I know, they don't have any commonality in the implementation of their parser, the way they represent the parse tree. Also, even CPython's parse tree changes with every version of the language. We might introduce a new feature, and as a result, the parsing of existing expressions constructs a completely different parse tree. Or someone might come up with an optimization for the parser, and the parse trees might look completely different. We've gone through a couple of serious changes to the internals of the parser in the past decade already. So Python is not one of those systems where the implementation of the language and the use of the language are all one big soup, like in Smalltalk, where every part of the Smalltalk interpreter is hackable. And if you ask me, that also has caused the death of Smalltalk effectively, because it meant all things that would want to call themselves Smalltalk were required to implement all that hackability, even if that wasn't sort of in the benefit of a particular implementation. So I encourage you to sort of come up with a kernel of an idea and bring it up in Python dev, where you say, we have these issues, and you can point to, there's this PEP and that PEP, and it would be so much easier if we didn't have to propose those PEPs and have to fight for them and still see them rejected, and instead we could help ourselves. But in order to help ourselves, we have to have some kind of hook into the parser. But you're sort of, the way that hook into the parser works, I'm not entirely sure how that API would have to be designed, and that is something where there's going to have to be interplay between core developers and the sort of the primary customer base, which would be NumPy developers.
And users, yeah.
I mean,
Well,
there's another example going on currently that actually for some mathematicians might also be interesting. There's someone who uses a variant of Python as a language for implementing sort of optimizations of certain types of mathematical algorithms. They're doing very highly theoretical work, and there's a lot of sort of proving things involved. It's very different from what NumPy does, although they have algorithms that do things like loop unrolling. The sort of number 1, 2, and 3 on their wish list is quantifications. And we've sort of, after a couple of rounds of discussions, I think we've boiled it down to they want exactly the same quantification syntax that Python, that ABC had 30 years ago.
Which group is this? You remember the name?
Her name is Annie Liu, I think.
Liu.
And I forget where she is.
Okay.
Somewhere in the East Coast, I think maybe some university in New York. I'll look
That'd be
it up.
great. What's quantifications? What does that mean?
Okay, so the syntax is, it's just the upside down A and the upside down E.
Oh,
That's how I think of
I
them.
see.
The Python notation would
Yes.
be if sum, where sum is a keyword,
Yeah.
variable in expression, where that expression is an iterable thing, has condition, where condition is an arbitrary expression,
Yeah.
colon, and then some body of code.
Yeah.
And the corresponding one is if each variable in expression has condition.
Yeah.
Why can't they do this with the existing any and all functions? Because you can trivially write that same thing and it will execute just as efficiently using any and the generator expression.
Yeah.
You write if any, which is a built-in function, left paren,
Yeah.
x for x in sequence, if
condition.
condition, close paren.
Mhm.
The reason why that is not enough for them is that in all the situations where they want this, they want to find the variable, they want to hold on to the variable that terminated the loop. So if you say if each x in blah has something, then it actually that variable x only survives when the condition is false. So in the else clause of of that if statement, the variable x is set.
Okay.
If you do if some x in sequence has condition, then of course in the body of that, in the then clause, x is set to the first x that you encountered, because of course it's a shortcut. It stops as soon as it finds one.
Okay.
And they need that example because then they do something else with that.
So that's
There's
it.
a whole sort of
Yeah.
many categories of algorithms in graph traversal that can make good use of this.
Yeah.
And so they have a whole bunch of grad students who are very bright mathematicians, but for whom Python is sort of something that they never really want to get very deep into it, except one or two of them. And so they'll commit atrocities like writing that condition using any, and then in the body of the if, they repeat the same thing in a slightly different form so that they can extract the variable that did it.
Yeah.
Things like that.
Right. Right.
Or they construct the entire set of all the matches and then they pull the first item out of the set. I think that's actually what they do is naively they construct the entire set. And they're lucky that it's not an infinite set, of course. And then they say if the set is not empty, then they construct the set again.
Right. So,
And then they use the first element from the set, and that's all they do. And sort of, if this was mathematics, that would be a perfectly fine way to do it.
hopefully you haven't run that
Yeah.
on MapReduce.
So anyway, that is another example of sort of a syntactic extension that is of crucial importance to some people, and that for a number of reasons, including the introduction of three new keywords, is a hard sell to the core developers. So some transformation mechanism that lets everyone sort of solve their own little problem, scratch their own itch, big or small, and that is sort of building on a foundation that is part of the language.
Yes.
Would be much more attractive for the core developers because first of all, they see it as an interesting, juicy problem. We have a parsing problem. We like those. And second of all, it is of obvious generality. We're not just solving the problem of one user. We can immediately conjure up in our imagination many categories of users who would be able to use this same feature for very different purposes.
How is that fundamentally different from macros?
Well, that's the trick. That's the trick. How do you make it fundamentally different from macros?
Well, I think I want to thank you for your very thoughtful answer on that, and I think exactly just kind of what you're saying there, and what we've seen is that Travis kind of said it earlier in this morning in his talk, and kind of the thing I keep saying kind of when I go and evangelize Python is that it is small enough to fit in people's heads that they can still get their work done and use it. And in all these cases, in the case of matrix multiply, in the case of the quantization, in the case of kind of in data analysis, you look at R flows a little better for some stat stuff and for some data munging stuff because it plays a little faster and looser with scoping and things like that, or with namespaces. In all these little cases, it's that Python is 99% the back scratcher we need to get our itch. Mm-hmm. But it's so good that the legacy, I wouldn't say legacy, but the decisions made syntactically to scratch the itches of programmers 20 years ago, 15 to 10 years ago, that kind of has friction with what the particular domain user needs. Yeah. And so if we have a system for doing DSLs, but not crazy macro, not crazy, now you can write whatever the heck you want to in Python, but really a way to robustly transform and have the interpreter still kind of reason about this and know this is a foreign thing I don't understand, but I'm not just going to say, oh my God, I'm going to die, right? So that is really what at PyCodeConf last October, I had a great conversation with Nick about this, and Armin Ronisher came up and said, oh yeah, I did exactly that import call. Someone else at Enthought has been doing this for declarative widget layout kind of specification. Everyone that we know that's got Python scratching 99% of the itch they just need that last little 1%, and it's not the same 1% for everyone, and it's certainly not a universal choice for everyone. But having the language being able to support that, and it is a hard thing. You're right, because the parse tree, that's something that's kind of internal to the implementation traditionally. The parser is not something you extend unless you're doing your Lisp style, really like you just define your own whatever, right? So, but I think that is a critically, it would basically put Python light years ahead of any of these other languages that have been built up really as DSLs or that are really well suited for solving certain categories of problems. It would just give Python big guns in all those areas.
It would allow that code reuse, though. I mean, that was the big thing. I used to be really against DSLs because I wanted everybody to write Python forever, only. Right? Of
course.
But I start seeing real power in mini DSLs. But you want those DSLs to only extend a little bit up, and then have a plateau where they actually reuse a lot of code from each other. And so there's always got to be a way to express that DSL in the library, in the language. So that sort of thing would just make that just sing. But it's a challenging problem. But one that maybe we can get a couple of Python devs who are interested in it to engage with us.
And there may be some kind of intermediate solution where you don't end up allowing arbitrary transformations at the parse tree level, but where you have some kind of hook to inform the parser of certain additional constructs that it should recognize. Maybe the quantifiers can also be expressed as some new operators.
Yeah.
Maybe some can be unary operators, and has can be a binary operator, and there can be some kind of idea in
a lot of
there.
our syntax issues would be solved by something like that, and maybe perhaps operators. The only one that's we haven't talked about is the literal ranges. Besides literal decimals, literal rationals, literal ranges. Sort of the ability to, instead of saying, it's often talked about this in terms of using the slice syntax and more outside of the brackets. I think there's other ways to do it, in fact. In fact, one thought was just use the ellipsis operator, kind of between 1 ... 10 would actually do a range from 1 to 10, right? Or
Why not
1
from 0?
3 ... 10, or 0, whatever, right? Use the ellipsis as a literal range. It's a very common use case that
Common enough that Sage actually, so Sage, which not everyone here in the room maybe has used or heard of, is a system that uses Python as its core, and it's completely built on top of Python, but it adds changes to the syntax of the language itself for the purposes of providing a more mathematically oriented language. And so it actually pre-parses at the textual level. Every single block of input is pre-parsed and transformed just as via text transformations. And one of the transformations that Sage does include is precisely this one. So A ... B is actually the list from A to B with B included. So instead of having the semantics of a range, it has the semantics of a closed interval, because that was deemed sort of very, very natural and convenient when writing mathematical codes. And I think in the NumPy world, people have talked about that too.
Whatever proposal for pre-processing or new operators or anything along these lines ought to take all these use cases and make sure that each of those use cases can be dealt with. Because once you have something that supports 3 or 4 quite different use cases, you can be confident that when someone comes up with a new use case, it will probably also be supported.
Yeah.
If you sort of generalize from one use case, you may come in for quite a surprise when you encounter the second.
Yeah.
So in terms of kind of concrete plans, one thing, we have a funky opportunity this time around, which is that PyCon is next week, and a number of us are also going to be here at PyCon. So maybe in the meantime, we can try to brainstorm a little bit amongst ourselves.
Yeah, maybe so.
And around PyCon, maybe we can try to have just
arrange a
over
BOF
beer or a BOF or something.
discussion and lightning talk to get people interested.
And see who has ideas on how to go about it. And
Gathering
who
use
knows?
cases.
Maybe there have been 50 people who have implemented a similar thing instead of just the 5 that you know about.
Exactly.
Yes.
One thing you might want to take a look at if you're curious about some historical work in this area is Quixote, which is a templating language.
Oh yeah.
Great.
Basically, it's a
Quixote.
Don.
Don Quixote.
Oh,
That doesn't bode well for achieving results. But
It was written about 8, 10 years ago, right?
Yeah, Andrew Cushling.
The web framework?
Yeah,
It was an
basically,
old
it uses a
templating
file
framework.
which looks very much like a Python program, but you have a different extension, and it functions a bit differently. It's a web templating language.
Yeah.
You know, there is actually a student, a former student of Dave Beasley's. He actually wrote an entire system for doing this, for doing parse time, compile time, interpretation time, basically a quote, a generic list quote for Python. He called it Mython. And actually, if you Google for Mython, you'll find, his name is John Reel. And so he has an entire framework he's already implemented for this, and he kind of has an import hook that does these tricks. But anyway, so these ideas have been explored in a more than just a templating system, but actually deeply thinking about the structure of the parsing steps and whatnot. So people have been kind of poking at this.
It sounds like a wheel that has been invented so many times that it might actually be useful to start standardizing how round it actually has to be.
But I actually very much like the direction this is going into, because if we manage to get this right and give the scientific community a way of solving all of these different little problems all in one clean shot, and it gives a layer, for example, for the Sage team to, instead of doing these things as textual pre-parsing hacks, to basically kind of clean up their implementation, maintaining what they want.
Yeah, all the transformations that Sage currently does should also be seen as use cases.
Absolutely, absolutely. That could actually be a very big win.
And if it turns out that one or two of their transformations are really hard to fit in a general framework, maybe those should be excluded.
Okay.
Should probably move on.
Yeah,
to
we
some
should.
other-
Perhaps one of the next. Should we go into packaging? Or?
Probably.
Because that one can be potentially a big topic. So we want to pass this one to David, who's from within the scientific community, probably the person who has thought and worked the most on issues around packaging and distribution.
And from the, I should say, from the Python community, I am probably the person who has thought least about the topic.
We'll take what we can get.
Let's hear it.
So I was just saying that, so basically we had our own infrastructure built on top of distutil in NumPy. And like one figure that I think is striking is that NumPy distutil is as much code as distutil itself, basically. And when there was some discussion about what would end up being distutils2 or packaging, like people were saying, like we should keep distutils as it is because it's used by a lot of people. And some people are scientific committee, but other people as well say, look, the problem of distutils are really fundamental that you cannot fix them without breaking the API, because one of the issues of distutils is that there is no API. It's not really written as a library you can extend easily. And then the problem is distutils2 happened quite quickly, and at least from my impression and some other people's impression, without much thought about what was broken in distutils and what to do to fix it in distutils2. And now it looks like distutils2 is yet another packaging tool that is yet different from the other ones and doesn't really solve anything for us. So it actually makes it more difficult for us.
I have to object against your representation that
Okay.
this happened very quickly, because this has been one of the most drawn out discussions in the core developer community that I can remember of the last couple of years. Maybe nobody from Numeric was sort of following the Python dev list enough, but I remember that Tarek Ziadeh was working on this for at least 2 PyCons in a row.
Right,
And
but
I think the first PyCon that he was working on it, he was already so frustrated that I actually had to have a talk with him to encourage him to keep going and not give up. And he was still working on it, the PyCon after that.
okay.
So
Well,
I don't think that it happened overnight. It may very well be that nobody thought to sort of look specifically at NumPy for feedback, because I personally wasn't even aware that you guys had your own installer that was as big as distutils. So
well, I guess, yeah, for me, because this packaging has been a long discussion, not just in numerical, but in Python community, for me, 1-2 years is, I would have caused that pretty quickly, given all the discussion before on setup tools. So
okay. Yeah, sort of that.
Yeah.
I guess nothing ever happens in the packaging world. That's the problem because, and then someone comes out with a terrible hack, and suddenly everybody adopts it, and then progress is being stalled for 7 years again. That happens with Philip Eby's
Right.
stuff.
Some of the main issues really were around the need to build extensions and kind of understanding that need and understanding the reason why NumPy distutils overloaded all of distutils, right? Because it had to sort of really just overload all of the pieces that distutils created. And at the end of the day, perhaps I think that was probably a mistake on our part, right? We were kind of trying to get code reuse and benefit from the registration mechanism that distutils was promoting. We could have gotten all that likely by just building our own system and then hooking in on those pieces.
Maybe you overloaded every single line of code in the original distutils.
Exactly.
So you didn't benefit from the
Correct.
the
Exactly.
subclassing at all.
We didn't benefit from it. Primarily, but it seemed like the discussion, and I wasn't a part of it. Some of the talking with David and talking with those who were, there didn't seem to be an understanding of the kind of build issues that NumPy and NumPy extensions have. Typically, you're building C libraries for sure, and then perhaps Python, certainly Fortran,
C++.
C++. You're building all these. So there needs to be a make system and the ability to integrate with the make system, and that was, I think, where some of the concerns were either not understood or not addressed, at least to the satisfactorily to David.
Yeah, I can
Nonetheless-
totally believe that wasn't addressed because the necessity of a make system in the context of building distributions is news to me.
We need fine control over compiler flags. For example, compiler flags in the distutils code flow in this very opaque way. You basically have to instrument the code and trace it to see when, this particular method, along the way, all of a sudden flipped a flag inside of a structure. There is no API for that to happen, but when you're trying to build something like SciPy, which is a layer of Fortran, Python, C, and C++, all of it wrapped in one, obviously you need very solid and clear control of things like compilation flags and which compilers to fire up, because they're not all API compatible. And so, and all of that in the context of these distutils is extraordinarily complicated and frustrating to do.
And do you guys have any interest in platforms besides Linux?
Yes.
Certainly, Macs are pervasive. Windows is still very widely used. And
So you
other
actually
Unisys.
have all that stuff with compiler flags and everything working on all those platforms.
Yeah.
If that's one of the reasons it's so big.
It's the outside packager who does it.
Yes.
Can you repeat that? Some of us outside packagers actually have to go in and fiddle with flags and
Yes.
reach way in where we don't really want to be reaching.
Who was just telling me that that's what they did? They have a whole host of flags that they wanted to get back to NumPy distutils, that they had to basically go through all the compilers and all the platforms. Was that someone in Austin, Peter? We have to check my memory.
You can patch it on the fly for Blue Jean.
Yes, Blue Jean is, I'm sure.
Because that's the other thing. It's also it's not just Linux. When I was trying to finish, it's also the other Unisys, like the Unisys and Big Iron, the Unisys, these funky Unisys that compile with much more exotic compilers on large machines, and doing that with distutils is a bit of a nightmare. I mean, I don't have the fortitude for that kind of code anymore. I abandoned distutils long ago and leave it to people like David.
Well, yeah, I guess like one of the impression was because we don't want to build our own make in Python or something because such projects already exist. And one of the things we have been trying to do is to one of the first things I've been doing is to integrate scans. I think you're aware of scans.
Yeah.
With distutils, and it kind of worked, but it was not pretty. And the new system I've been working on, which is generic enough to be used outside NumPy, SciPy, is just written as a way so that you can plug an existing tool, because I'm not interested in writing yet another Python make replacement, and to build with this. And
you may have no choice. It really sounds like your guys' needs are so unusual compared to the larger Python community that you're just better off building your own.
Or using a make system, just requiring a make system.
Well, of course, across all the platforms you mentioned, there's no chance of a single make system to working for all of those either.
CMake work on the blue gene?
CMake probably does, right? Does CMake run on Blue Gene? It must. No? Someone say no?
Who here owns a blue gene?
All right.
Yeah, I'm not sure.
I guess mostly just wanted to be able to make you aware, I guess, of some of the, I think there is, and we recognize this because we're not as vocal and visible all the time as we'd like to be, but there are real significant use cases for packaging that aren't necessarily addressed. That's okay. It's like Python doesn't have to address all those issues, but just providing the ability to hook in and not making it extremely difficult, so essentially we can't use it at all, which is really probably what we should have done in the first place.
And maybe that is the answer. Yeah, maybe just that is the answer.
For this particular situation, it sounds like you guys know quite well which compiler flags you need to set, and you have access to all the machines where you need to test your build scripts or your make files or whatever.
It may just be a different use case, and we have to bite the bullet and do our own sort of.
By now, with all of the energy that we've burned on that,
Yeah.
we would have finished.
No, I know, we totally would have.
You might,
David's finished
well,
twice already.
if your existing thing works, except that it sort of extends distutils, which is going to die, your best approach might be to sort of
Clean slate.
well, that's so you can rewrite the whole thing from scratch, or you could sort of do surgery where you replace the lowest level of your tool, which is currently based on distutils, with your own copy of that code that you import from a different subpackage, so that you have everything in hand. I mean, there's no reason why you couldn't just copy distutils and sort of systematically change all the imports so that you now owe that code.
So at this point, it's integration with PyPy, I guess, is the only. I mean, at that point, I don't see any reason why we couldn't still integrate with PyPy.
Yeah, we could still do it because it's just a couple of API
Python
commands,
package
right?
index, right? The PyPy.
Oh, PyP, yeah.
PyP, sorry.
Cheese shop.
Cheese shop.
Cheese
thank
shop.
you.
But that's just register and upload, right?
I don't think that there is a particular requirement that you use the standard packaging tools. The standard packaging tools provide good integration with PyP, but there's no reason that you couldn't add your own integration, because as far as I know, the interface between PyP and the packaging tools is sort of
It's a RESTful
standardized.
API, right?
It's standardized.
It's standardized. There's probably a PEP that describes it.
Yep.
So you can just write your own implementation of that client.
And it's actually a fairly small API because it's a handful of
One,
commands, I
yeah, I'm
think.
sure. It's like
Register,
a bunch of
upload,
metadata and upload a
register the metadata
file.
and upload
and-
the data. I think that's it. I like that idea, especially because the we who has to do the work is sitting 2 chairs to my left. So.
That's great. Anything else, David, you want to comment on? No, it does sound like that's certainly something we have to take on. One question I have, I guess, it's maybe a little bit out there, is we have 4 implementations of Python that are popular: PyPy, Jython, IronPython, CPython. Is there any, and there's been a few approaches, Unladen Swallow was one attempt at a new implementation. Are there any projects you're aware of, or anything you're aware of a new CPython implementation, or a new runtime implementation that's compatible with some of the CPython APIs, but perhaps trying to do other things, clean up certain other aspects of the runtime?
I don't. Well, every once in a while, I sort of see a floating reference to a Python implemented in some other random famous language like Lisp or who knows,
JavaScript.
Haskell, JavaScript. Yeah. I'm not aware of any of those that need to be taken seriously.
Okay.
I mean, it's IronPython, Jython, PyPy, and CPython, and then there is Cython, which is sort of has a special symbiotic relationship with CPython.
But also IronPython. I mean, one of the ways to get NumPy onto IronPython was to actually, or SciPy more particularly, was to write a C# backend to Cython, and then use it as the generation language.
Oh,
and so
okay,
it essentially has a C#
I wasn't
backend.
aware of that. That's actually pretty cool.
Dag was here. He was involved with that work. It didn't.
I mean, the IronPython backend for Cython was, it got just far enough to generate what it did for scipy.net and then it died.
Yeah.
I mean, it,
Well, so Microsoft sort of stopped being excited about R and Python, right? And that certainly took the air out of the room, and developers went elsewhere.
Well, I can also see that the typical code you write in Python has some dependency on native APIs, and those native APIs are different on every platform. So even if you could write a Python translator that targets C#, the typical piece of Python source code would still not be all that useful on that platform, because it's not just a subset of Python that happens to compile faster, but it's also an extension of Python that lets you call all kinds of funky things in either directly in the C Python API, Python C API, or just in libc or whatever other library you happen to have loaded. OpenSSL is probably popular.
Yeah. Doug,
So that
I believe it was
none of
managed
that
C++,
code would
wasn't it?
really be very successful.
Didn't the Python, the .NET backend of Python use managed C++, or did it emit C#?
it uses, no, it used C++ CLR.
Yeah,
So that
managed
it
C++,
could,
yeah.
It didn't worry about, so it could keep using the API in the header files rather than having to use an API, a binary interface, which would have broken a lot of Python code. But certainly, we've been thinking about like having a subset of Python work. I mean, have Python work as kind of a lingua franca for wrapping C code.
Yeah.
Basically. I mean, in addition to C types for people who don't want to use C types.
Has anybody tried Python and PyPy?
Yes, there was a Google Summer of Code last year, and the aim of that was to create a PyPy backend for Python, basically. And I don't know too much about it, but I think the approach was to generate C types code from Python, or something along those lines. But there's certainly things. I mean, there lately as well. There has been discussion about PyPy and Python. There definitely, but I don't know too much about the details.
Okay. There's some attempts. Okay.
Does anybody from the audience have any questions? We have a few more. Yes.
Yeah, I want to bring up the import problem.
So I was going to ask, are you Asher?
Yeah.
Okay, so we discussed partly some of that over lunch,
Yeah.
but it would be, maybe you can summarize how you see the discussion that we had and can kind of pick it up from there.
Well, I would like to invite you to sort of explain what you observed. And
Asher, why don't you actually do it through the microphone, since it's kind of one of the topics for the discussion, so that it ends up being recorded.
we have a new panelist. Excellent.
Okay, so what we saw, this is at Livermore. We're running on BlueGene P right now with 32 or 64,000 cores. And what happens is we go to startup, we import. And so I had a trivial example, 100 C extension modules, one function each, trivial, not large. It takes at 32K processes, it takes about 25 minutes to get the interpreters going, which sounds like a long time to some of you, but actually that's okay. And then it took 5.5 hours to load the 100 modules. And so I had a student last summer, we worked on a hack that uses MPI to, the rank 0 process goes through and finds out where the module is and broadcasts that information, and everybody else waits. And then everybody goes out to the file system and gets it from that location. And everybody's still hitting the file system for the actual modules. It takes 5 minutes instead of 5.5 hours. And it, when we have 12 or 24-hour block allocations, that's the difference between getting a run done and not getting it done. So that works pretty well, and people have done other things. A few people have hacked the interpreter to use MPI for all of the loading. I looked, actually, Dave Beasley did that 15 years ago, and it's been redone at least twice, I know. And that'll never get upstream because you don't want
Well, wait a second. Upstream has all the import hooks you need to help yourself there, right?
Well, like PEP 302, because
Yeah.
that actually that looks really promising, but that requires knowing where, because it uses the location and file name to decide what loader to use.
Yeah, but there's also a meta hook that you can put in front of that. I promise you that the import module has already enough hooks to help you.
It does. I can guarantee it does.
Okay, so
It
you,
took me a while to figure out what those hooks were.
yeah,
Yeah,
yeah.
well, yeah,
Once I
that's
did, I
problem.
realized it was actually a
It's
solution to a lot of
it's
problems people have.
absolutely there.
So
I mean,
yeah,
I'm
if we-
also interested in understanding what takes 25 minutes to start 32,000 interpreters. Do they all sort of sequentially check in with some central locking device or something?
It's just well, it's the import problem, but it's before we can get a hold of it. In that case, it's still importing all the stuff that starts the interpreter. What really kills us is all the failed fstats. That it goes through and says, hey, I want NumPy. Let's check the first directory. Is there numpy.py? Is there numpy.pyc? Is there a NumPy directory with an it?
Yeah, so that particular probing algorithm is completely overridable.
Yes. So actually,
Okay.
there's a registration mechanism that I sort of
Yeah,
put into EPD. And
yeah.
you could do something very similar, right? And it's actually useful for versioning of packages too. You can have a virtual M that's just simply file-based, right? With this Python run with this file, you know exactly where you're importing everything.
Yeah.
It
I mean,
actually works
we ran into a similar
well.
problem probably 15 years ago, not with a multi-processing solution, but just with running a large app that was doing hundreds of imports, and everything was much slower. So hundreds of imports was actually a significant number of imports, and it was doing it over NFS. And just as you say, there were lots of stats, and it turns out that NFS in general, stat is the absolute slowest system call in the entire system, because apparently it insists on always giving you uncached fresh information. So it hits the server that has the actual files every single time. And so our solution was that, again, we just overloaded the entire import machinery, which even 15 years ago, before PEP 302, you could do that. And we sort of, I think what we did was, instead of we didn't do any stats. For every directory on sys.path, we did a read dir, which reads the contents of the directory once, and we loaded that into a dictionary. And then we just do a check in that, is the file name in that dictionary?
And that's exactly what I think the correct solution for our use case is, because the problem with the MPI solution is, well, one, it depends on MPI, and two, it requires the code to be synchronous. And so you have to sort of turn this behavior off and on, because otherwise, you know, if some rank wants to import something that rank 0 didn't import,
Yeah.
it won't work. So you have to minimize where this happens. I thought, so there used to be, before PEP 302, there was a way, wasn't there an option to actually do this sort of caching? That's what I was told, although I couldn't find a discussion of it, that at one point there was a way to just cache everything.
Well, you can override under, import under.
That's
any way you want. There's also a command line option -S that stops it from doing any imports as part of the setup. So when you start a Python interpreter, say you start it interactively or you give it a script, before it gives you the interactive prompt, it probably imported 50 or 100 standard library modules.
Yeah, and that's a 25-minute.
You can drop that to 0 by using capital S on the command line, -S on the command line, because then it just says, okay, I'm not going to import the setup module, not even going to look for it. It has a very simple sys.path, and then it's up to the script or the interactive session that runs to manipulate sys.path or other import hooks to find the modules.
So at that point I could build, because we want to build this dictionary.
So you exactly what you do then is you sort of import the absolute minimum of stuff that you absolutely need. I mean, if you you probably need some file system access. So you can
Yeah.
you can import the POSIX module, which is a built-in module instead of the OS module, which is written in Python, and you have pretty much the same APIs.
Okay, so I'll have to go back and look at the meta path.
Yeah.
Is that, because
I'd like to sit down and talk with you about it, actually.
yeah,
Your use case, I've heard of it multiple times, and it seems like it seems like it's solvable.
yeah, and people there are. I know of at least 3 or 4 different groups. Someone at Berkeley Labs, someone at Argonne, a few other
Somebody
places.
at Argonne doing
Everybody's redoing this, and at different levels. Some people are doing it.
Live C.
Yeah, someone else at Livermore is doing it with a LD preload trick where they're throwing something in front and doing this sort of caching, but actually at a lower level than Python, just sort of an OS level. But it's a hack. I mean, you're just shoving something in front of the system libraries.
And I assume that I remember from our lunch conversation actually that one of the fundamental problems why this is such a big deal is that these are actually diskless nodes, right?
Yeah, and that's
Because if I had to solve the same problem at Google, in a Google data center, I would make sure that the entire Python standard library was on the local disk. And import from local disk is fast enough that
Yeah.
you don't
and
have to worry about any of that. But
we'd love to
if you're diskless, of course, you have a very different proposition.
Yeah, we'd love to do that too. Problem is, a local disk doesn't make linpack run faster, so it's hard to get machines spec'd to solve that problem for reasons outside of our control.
You have a question there.
A couple of other things. There's stay there. You should look into zip imports.
Yeah.
That would concentrate all your imports into a single file, which would make it a lot more efficient.
Except, I mean, he was talking about 100 extension modules, and those can be loaded easily from zip, not without local disk.
This was to sort of simulate the actual code we use. This was that was just a
Sure.
standalone.
Yeah. The other thing is, you really want to get away from NFS. You should probably talk to someone who's a real sysadmin about the different options that you have for that. But I mean, just as a for example, even if these are diskless nodes, you should be able to create a RAM disk.
Yeah. Although unfortunately, RAM.
Yeah, they're short on memory too.
That's a different issue. I mean, but that is.
But I mean, I'm just saying, one of the exercises we've done at my work recently is get rid of every single NFS access, and it's amazing how much of an improvement that makes, not just in speed, but in just plain system reliability. Yeah. Just don't use NFS.
Yeah, and we are using other file systems, and some of them, are file systems we can treat as read-only, and therefore get a lot better caching, but it still doesn't help us when it comes to failed lookups.
And all your imports could come from a read-only file system,
They
obviously.
could. They could, but it still doesn't. The implementations still don't handle the failed lookups very well, and that's more of a vendor issue. But so we have to work with what we have, unfortunately, and we have control over.
You only paid like $10 million for it, so.
That would be probably a severe underestimate, but unfortunately.
Well, for 32K nodes, that's not a bad. That would not be a bad price.
Yeah, the problem is the machine we're getting now has 1.6 million nodes, and if we're going to take advantage of that, I mean,
you clearly want to parallelize this last bit.
Yeah. If it takes us 3 or 4 weeks to get to the prompt, we're going to have problems.
So much for the interactivity of Python, right?
Yeah. This is all running in batch mode, at this scale, but yeah.
Did you have anything?
No, that sounds
so
like a good conclusion.
Yeah, we're kind of wrapping up. The one comment.
Can we talk about the JavaScript?
That was the one comment I was going to make.
Did you plant all those people in the audience?
He is my postdoc, so I could have, but no, I didn't. So the one comment that I think we wanted to make from our community towards the standard library and towards the Python core dev team is the importance of interactive doc strings in general in libraries. We have in the NumPy, SciPy, Matplotlib, etc. world, we've sort of, because we work so often interactively, we've gotten into the habit of writing good doc strings, and we even have a doc string standard, the NumPy docstring standard, which is basically very simple REST with a few sections that gets automatically formatted, and even tools to make it very easy to edit and improve doc strings. There's a web editor so that anyone can basically edit and contribute patches to the doc strings without having to even have Git or version control installed or anything at all. And over the years, this combination of a few technical tools, some standards and practices have led to a very, very pleasant situation where most work that you do with these libraries, you can find out what you need just by looking at the doc strings, and IPython displays those in a number of manners. And it's often very frustrating whether either when we're working alone or teaching, if we need anything from the standard library, we're lucky if there's a doc string that says anything useful. The docs tend to be very good, but you have to go to the HTML build. The interactive doc strings tend to be, they range from fairly low quality to non-existent.
Very too poor.
Exactly, and so this is sort of something that at least we'd like to plant a bug in the Python core kind of brain that it would, we think, improve significantly the usability of the language at large, and we're very happy to share the tools, the experience that we have. The tool chain is quite good, and I think it would be great actually if there was a doc string standard that was language level. I mean, PEP style, obviously, something that was reasonably widely accepted and adopted so that there would be more uniformity, because then we could put, it would be much easier, for example, in IPython, which is our interactive entry point, to put help searchers that index these things well, that provide users. If you look at the quality of the help system of a system such as Mathematica or MATLAB, the help system in Mathematica is a work of art. It's absolutely spectacular. It has an excellent index, it has its own search, and it produces pages with very good reference. So users work interactively in those systems very, very efficiently. And that is one thing that when they come from Mathematica or MATLAB into Python, they sort of see, whoa, this is really terrible. You're telling me that the best you can do is tell me to go Google what I need. And so it's just something sort of to put out there for, I don't know, discussion to see if it's a seed that grows over time in the Python core community.
Well, you're proposing an inordinate amount of work here, because we have very good documentation that was very intentionally written out of line, not as part of the doc strings. So we have much more freedom to sort of emphasize things, group things, show examples that cross multiple parts of an API, de-emphasize things that are not so important, use much richer layout, and you're somehow requesting that we put all that in the doc strings, which even if we have had a room full of people here who would all help out doing it, it would probably still take a year.
Well, I don't think it's...
You underestimate how big the standard library is, I think.
No, because that's not what I'm proposing. What I'm proposing is, that over time, I wasn't proposing anything being done wholesale, that over time, basically, there's a practice of better doc strings in the standard library for new code.
Yeah, okay, so then this comes up occasionally on Python dev, and you can't really expect us to write all the documentation twice. So we've made a very solid commitment to having external documentation. I'm not entirely sure how to build that interactive system, but we can generate different formats from the external documentation. It's not tied to HTML. There's a sort of output neutral input format. And there are tools that generate different kinds of output from that already. If you have a need for a different kind of output, we can generate that. If you want some kind of indexing, so that if you have the name of a class or a function, your interactive help system can find exactly where that thing is described or sort of mentioned in the offline documentation. I think there's enough markup in the input for the documentation
to build those indices
to do that.
Okay.
the doc strings, the way they are in the standard library, and then of course there's lots of extension modules where the doc strings are included in the C code, which makes it extra complicated because there's less metadata available about the arguments there. I don't think that you can get people to agree that we should abandon the practice of writing good external documentation and instead start writing good doc strings. So it's one or the other, and we have too large an investment in tools that do external documentation really well. So I agree that the help function that currently just prints the doc string and does some kind of introspection of an object to print other stuff is often grossly inadequate. It prints way too much information in most cases. Like you ask help about a class and it gives way too much details. I mean, the typical class ends up having 100 different items of information about it if you include all the built-in operators that it overloads or inherits and all the little bits of data, and 3/4 of that are usually
useless.
Not, that sort of were never intended for external use, and half of the rest are not very interesting or have very low quality documentation. So that I agree that a lot needs to be done, but I think we shouldn't search for a solution that requires us to completely rethink where we write the documentation.
Mm-hmm. No, that makes sense, and that idea of perhaps building indices that we could hook into from IPython actually does sound promising, and that's the kind of thing that we could turn it into a project for someone.
And also the HTML that is generated has lots of anchors that you can link to.
Yes,
you
and
can link to, I mean, you have a page that describes an entire module. You can link to every single function or section in that.
Yes, directly.
In that page.
Yeah. No, I've seen those anchors.
Those anchors, as far as I know, are also quite stable.
Yes.
They're not just random numbers. They actually are derived from the text, or the function name.
They're from the text, yeah. The approach that has been taken in most of the scientific projects is to have two sets of documentation but not duplicate. So there is more of what we call narrative documentation, which is sort of higher level explanation, and then the doc strings build the pure API reference. And so that is how many of our projects have evolved.
And that is a perfectly fine approach. It's not the only approach, and it is unfortunately miles away from the core language's approach. And I give you very little hope that you'll be able to get us to make a 90-degree turn there.
No, but I like that idea of perhaps working with the hooks in there to either generate or scan or have a place where we build these indices and then we expose those indices in an integrated manner, because then within our projects we can follow a different set of conventions and index those, but simply ensure that for the pieces that are from the standard library, which we can very easily detect by introspection, because whenever you ask on an object, we know where it comes from.
Of course.
Then for those, we can query into these indices and
the way to invoke help in IPython, at least, is different than in core interpreter anyway.
You type question mark.
You wouldn't even have to overload the help function.
Oh, no.
But if you wanted to, you could.
No. We have our own inspection machinery. Yeah, we have our own introspection machinery. No, that's very useful. Thanks. So we were supposed to be here until 5, and it's just about time. So unless anybody has a final question or any final points, it's probably a good time to wrap it up. And I'd like to thank Guido for taking the time to speak with us. For me, this has been extremely useful and helpful.
Yeah, I don't know. There's not very often that the scientific community can actually say thank you to Guido. I mean, it's the language you gave birth to and allowed us to kind of co-opt and jump inside and use has been just revolutionary and really, really helpful to all of us. So thank you. Thank you very, very much.
Thank you. My pleasure.
And thank you for taking the time to have a discussion with us and give us some insights.
It's fun. I like to meet users, even if I like to rib them a little bit.